So what is up people, welcome to the new video, and in this video we will be covering a complete Pulumi crash course. So Pulumi basically an infrastructure as code tool which allows you to use your familiar programming languages like JavaScript, Python or Golang to provision your cloud infrastructure. It is not like Terraform where we use HCL HashiCorp configuration language for provisioning the infrastructure, but here with Pulumi you can use your own familiar programming languages for provisioning or automating your infrastructure, right? So these are some chapters which we will be talking about. First of all, we will see what is infrastructure as code. Then we will have a quick introduction to Pulumi. Then we will see why we need Pulumi if some other infrastructure as code tool are there in the market. So then we will see the Pulumi architecture, then we will explore Pulumi project structure, then we will see how you can provision your AWS infrastructure with Pulumi using JavaScript programming language. Then we will see how you can provision your AWS cloud infrastructure using Python programming language. Then we will see how you can provision your GCP Google Cloud infrastructure using Pulumi and JavaScript. And then we will see how you can provision your GCP infrastructure using Python. So here it is Python, and then we will cover a complete hands-on project with Pulumi where we will deploy a React application to Kubernetes on G-Cloud GKE cluster, and we will use Pulumi for the deployment. So let's get started. So what exactly does that mean by infrastructure as code? So it is basically a practice of defining and managing infrastructure using code and software development techniques. So what does that mean? It basically means like you can create and build or provision your infrastructure also same like your software application by writing your code, right? So with ISE, infrastructure can be treated as code, allowed it to be versioned, tested and deployed like any other software application. So what is the benefit of that? So here are some benefit of using ISE. So just like consistency and reproducibility. What does that mean? So it basically mean like let's say you want to create some infrastructure. Let's say you want to create some AWS EC2 instance or a virtual machine. So whenever you are creating, so let's say this is your instance you are creating, you will have some configuration for this specific instance, right? So you will define some configurations on for this instance. Let's say it is a EC2 instance you have deployed on AWS and you have defined some configurations, right? So these configurations you have defined for this instance. Let's say after that this instance stopped or deleted or corrupted or something, and now you have to create another instance with the same configuration that you did. So you have to again create all the configurations or manage all the configurations that you have done in this EC2 instance, right? So but if you use ISE, so what you need to do is you can add your whole configurations inside your ISE file, your configuration file. So it basically provides a declarative way to create your infrastructure or provision your infrastructure. So you can write your code here, and in your code you can define what are your configurations, what are your requirements you want in your infrastructure. And let's say you have deployed your EC2 instance using ISE, let's say it is corrupted, you can again run this ISE file, this configuration file, and you can again deploy the another EC2 instance or another infrastructure with the same configuration you did in the last one. Another benefit is scalability. So ISE enables infrastructure to be quickly and easily scaled up or down, so as needed. So this is especially important in cloud environments where infrastructure resources can be provisioned on demand and then deprovisioned when they are no longer needed, right? And another benefit is version control. So with ISE, infrastructure code can be stored in version control system, just like you can store in GitHub. And you can control your versioning of your infrastructure as code in your Git repository, right? So this helps you to ensure that changes are tracked and documented, which can be especially important in regulated industries and when managing complex systems. So another benefit is faster deployment. So IAC enables infrastructure to be deployed quickly and easily, which can help you to accelerate your software delivery and reduce time to market. So another benefit is, and very important benefit is automation. With IAC, you can automate your provisioning of your infrastructure. So it becomes possible to automate many aspects of infrastructure management using IAC, which can help you to reduce the workload on operation teams and improve the efficiency. So also this can help to reduce the likelihood of human error, which can be a common cause of outages and downtime. Let's say some human is creating some two instances and again with the configuration, so there can be a human error. But once you have already defined all your configurations inside this configuration file, then you don't need to again and again writing the same configuration. You just need to run it, so there is no longer chances to be any human error. So So let's get started with Pulumi here. So what is Pulumi? It's basically a IAC tool that allows developers to create, deploy, and manage cloud infrastructure using programming languages such as JavaScript, Python, and Go. So with Pulumi, developers can define infrastructure using their familiar programming languages like Python, JavaScript, and Go, and it enabling them to easily automate the deployment and management of their applications and services. So it's not like Terraform where you need to learn a new kind of syntax like HCL, HashiCorp configuration language, where you will need to write a complete different or weird kind of syntax for defining your infrastructure as code. But you can use here with Pulumi whatever language or programming language you are proficient with. Let's say if you are proficient with Python, so you can use Python programming language. If you are proficient with JavaScript, so you can use JavaScript. You can use Golang. So now, why you should use Pulumi or over any other IAC tool? So, so main benefit of using Pulumi is you can use your familiar programming languages. So you can define your infrastructure using your familiar programming languages like Python, JavaScript, and Go. And also it supports strongly typed languages like Go and TypeScript, so which provide additional safety for you. And here you will use real programming constructs. It's not like Terraform where let's say if you need to add some looping or some conditions or functions, you need to handle a weird kind of syntax. So that is uh, here you can use your real constructs like you can define your loops, your functions, your conditions, same as you define for your building your software applications using your programming languages like in Python, in JavaScript, whatever language you want to use, you can, which you are proficient with. So Pulumi supports a wide range of cloud providers including AWS, Azure, GCP, Kubernetes, Ali Cloud, DigitalOcean, vSphere, OpenStack, Oracle, and Cloudflare also. So, so let's discuss about Pulumi architecture. So Pulumi basically has these some main components like Pulumi CLI, Pulumi SDK, Pulumi engine, resource providers, and state storage. So here you can see in this flow chart, we have providers. So what are providers? So providers are responsible for interacting with cloud APIs, like if you are using AWS, Azure, Kubernetes, or GCP or something. So Pulumi includes built-in resource providers for many popular cloud platforms, and also additional providers can be added as needed. So it has same like Terraform, it manages state. So Pulumi stores infrastructure state information in a backend storage system, which enables it to track changes to infrastructure resources over time and manage dependencies between resources. You can use any Pulumi cloud. So Pulumi cloud is there, and you can use GCS bucket, Google Cloud Storage bucket, and also you can use S3. So you can even use your local machine for storing the state. And also, so here what is Pulumi engine? So Pulumi engine is responsible for executing your infrastructure code and generating resource manifest or deploying changes to your target environment, cloud environment. And here what is Pulumi CLI? Pulumi CLI is basically command line interface for Pulumi. You can download Pulumi and install on your command line, and you can use. So you can interact with Pulumi using CLI. It enables you to create, manage, and deploy infrastructure using your favorite programming languages. What is Pulumi SDK? It's a set of libraries that enables developers to write infrastructure code in their favorite programming languages, such as like Python, JavaScript, and Go. So it is same like whenever in Python you import some package, or in JavaScript you import some package. So Pulumi SDK provides packages for every provider like GCP, AWS, it is, etc. So now let's discuss about Pulumi project structure. So whenever you will create a new Pulumi project, so it will create a new Pulumi project. You can create using a Pulumi command, that is Pulumi new. And when you run this command, you can create a new project. So your new directory of project will be created. Inside your project directory, you will run this command, and your new project will be created. And inside your project directory, you create your program. It can be in your favorite programming language, or in like JavaScript, Python, or Go, right? So here you will define your resources. So same like Terraform, resources basically means what you want to create for your infrastructure, and these can have inputs and outputs, every resource. So here another component is stack. So let's discuss about stack. What is exactly stack in Pulumi? So here you can see every Pulumi program is deployed to a stack. So stack is nothing but it's just like to denote different phases of development, such as like development, staging, production, or feature branches. So you can separate your environments, your application environments, or project environments, such like development, dev, prod, QA, or staging, to different stacks. So you can basically have only one configuration for your infrastructure, and also you can use different phases, development phases, for your application or for your project, for your configuration. So what are Pulumi projects is any folder that contains a pulumi.yaml file, and when in subfolder, the closest and closing folder in pulumi.yaml file. So pulumi.yaml file should be there. It determines the current project. A new project can be created with Pulumi new. So Pulumi new is a command to create Pulumi new project. So now let's go through our very basic Pulumi project structure. We will create a new sample Pulumi project, and we will see how we can work with it. So I have already installed Pulumi. If you want to install, you can just go to Pulumi documentation, and you can see how to install Pulumi CLI on your local machine. So now if I run Pulumi command, so you can see it gives me a lot of options here: Pulumi up, Pulumi stack, Pulumi config, Pulumi destroy, and it's saying to begin working with Pulumi, run Pulumi new command. So now let's run Pulumi new command. So before that, if you are not logged into Pulumi cloud, so you can log in, but if you don't want to create a Pulumi cloud account, you can log in as local. So it is saying we are logged in into my local. Now what we need to do is Pulumi new. Let me create a new directory here. Let's say introduction, or let's say getting started, and go to this directory. Now I will run Pulumi new. What I want is I want to initialize a project for GCP. So I will say GCP, and I want to use language JavaScript, right? So I will use like Pulumi new GCP JavaScript, and I will hit enter. So it will ask me something like project name, getting started. I want to keep the same. You can leave it default. Stack name, dev is default. You can provide your own stack name. I keep it same here. It is saying dev already exists, so now prod, greatest stack prod. And GCP project, you can provide your GCP project ID here. Let's say I'm not providing for now, but it is installing the dependencies. So let's wait for some time. It will install all the dependencies that are required to start working with my GCP provider. Okay, so my project is ready to go now. So now let me start it in VS Code. So here we are. You can see the directory structure here. We have a pulumi.yaml file. We have a pulumi.prod.yaml file. So it is for production environment. It is for my stack. So how we can check the stacks. We can run the command pulumi stack ls. You will see we have 3 stacks here: dev, prod, and staging. So now what we want to do is, let's say my default stack is prod here. I want to assign my GCP project here. How I can do? I just need to go to my GCP cloud and I can copy this, my project ID, and I will paste here, right? So now I have here in the code, you can see it is a code for basically creating a new GCP storage bucket. So name is my bucket and it is basically a JavaScript file, complete JavaScript syntax. You can use your favorite programming language JavaScript, or Python. If you need to run in Python, you can use Python also. And now how you can do how you can create your infrastructure using this code. You just need to run the command pulumi up. Just hit enter and it is creating. And now just do yes, and now it will say creating and creating. So it is creating a stack, that is prod, and inside that prod stack it created a bucket, a new bucket. So now how I can remove this, how I can destroy my infrastructure, I just need to run the pulumi destroy command. So now my infrastructure is deleted. So this is the quick restart with Pulumi. We will see a lot more about Pulumi. We will create more infrastructure with Pulumi for AWS and GCP. So please stay tuned. So now let's discuss how you can manage or provision your AWS infrastructure using Pulumi. So with Pulumi, you can use your favorite programming languages like JavaScript and Python, and we will use Pulumi to manage our AWS infrastructure. So as AWS, you can use Pulumi for managing all your mostly your popular cloud providers like GCP, Azure, and a lot more. So let's see how you can use Pulumi to manage your AWS infrastructure. So here, let me create a new directory for, so first of all, we can use multiple programming languages. So here I will use Python and JavaScript. So first we will use JavaScript. We will see how you can use JavaScript with Pulumi to manage your AWS infrastructure. So I will create a new directory for JavaScript and AWS. So I will say it mkdir, and I will name it like JS AWS infra, right? And we will go into it. So now, as you know, in the previous section we discussed how you can create a new Pulumi project. So you can run Pulumi new command. So before that we will log into Pulumi as a local. So we will use file here. So basically file means I will provide where my state backend will be stored. So I want to store in my local. So I will say dot, so because in this current directory, and I will say enter here. Now it's logged in. Now if you ls, so you will see .pulumi directory is created here for the storing Pulumi metadata and the backend storage like state storage. So now we will create a new Pulumi project using Pulumi new, and we want to use JavaScript for AWS infrastructure. So we will take the template for AWS JavaScript. So it's saying it's not an empty directory because we have created .pulumi folder here because, and now let me create a new directory for writing my Pulumi code, and I will say it like mkdir infra or Pulumi scripts or something, right? Pulumi code, let's say cd Pulumi code, and I will create a new project here, Pulumi new AWS JavaScript. So it wants some project name, project description, stack name. For region, I will provide the default US East one. So now it's installing the dependencies it need for JavaScript to use Pulumi for AWS. So it will install Pulumi AWS and Pulumi. So now my project is ready to go. If I do ls, I will see these files here. You can see Pulumi dev.yaml, pulumi.yaml, index.js, and a lot more. So I will open it in VS Code. So now here you can see, so this is my index.js file. So here you can see there is already exist code that will create a bucket, my s3 bucket for name my bucket right here, and this .pulumi folder, we don't need to care about it. And if we go to pulumi.yaml, you can see runtime is node.js. If we go to pulumi.dev.yaml, so this is a file for settings of our basically dev stack. So if you do run Pulumi stack ls, so you will see there is a stack that called dev. So this is our dev.yaml file. So now if we want to run this code, we want to create the infrastructure for AWS. Let's say we have specified like we want a bucket. The bucket name should be my bucket, and so we can run Pulumi up command here. So it has created two resources. So my bucket name is my bucket this. So if I go to my AWS console, I will go to S3. So I can see my bucket is created, name it my bucket this, right? So now let's say we want to create a EC2 instance also. So my bucket is already created, so it is stored in the state that this bucket exists, right? Now I want to create a new AWS EC2 instance. So what I will do, let's say I will comment down, create an EC2 instance. So now what I will use, I will say const instance is equal to new AWS dot EC2 dot instance, and here I will provide the name, let's say my instance. Now in these arguments I will provide it the metadata for my AWS instance. So for AMI, I will provide it Ubuntu AMI. If you don't know what is the AMI ID for the Ubuntu, you can go to your AWS console and you can go to EC2, and if you go to AMIs, you can see AMI catalog, AWS, Mac OS, and if you go for, you will find for Ubuntu here, it is the ID for Ubuntu, right? So now I provided AMI. Now I want instance type. I will provide T2 micro. Okay, t2.micro. Now key name. So what is key name? It is just for my connection with my instance using SSH. So it is a SSH key pair. So I have these keys here. So I will provide this Kubernetes persistent key that I already have. If you don't have, you can create a key inside your AWS console. Now I will provide some tags for defining the name of my instance. So I will say name. I will say my EC2 instance. Now if we go to AWS console and here we go to instances, we'll see there is no instance that is created now. So if I do Pulumi up now, I will do yes. So it is creating now. So it will take some time to create the new instance, as it need some time to run the instance also to boot up the new virtual machine. So now it is saying it is created. So now if I do refresh here, I can see my instance is created and it's running, right? So now I will destroy this, all the infrastructure I have created. So my bucket is deleted and my stack is deleted. Now my instance is also deleted. If I do refresh here, I will see it is terminated now. So this was the process how you can use JavaScript in Pulumi to manage your AWS instances. Now we will see how you can use Python also for using the same, right? So I will do cd now again. So I will create a new directory, Python AWS infra, and here if I go to Python AWS infra, I will do ls. Now let me create a new project here, Pulumi new AWS Python. Stack dev region, I will provide US East 1. It is creating a new virtual environment as well, right? You can see here. So now it's saying my project is ready to go. If I do ls, I will see it is created a VNV virtual environment for my Python scripts, and here is my main script. If I do code dot, I will open it in VS Code now. So now here you can see this is my Python program, and here you can see it is also the code like for creating the bucket, the S3 bucket. Now I will open it a new terminal here, and now in the terminal you can see I am inside a new virtual environment, that is VNV. Now if I run this, how I can run this file? So now when I want to run this code and I want to create my S3 bucket using Pulumi and Python, so what I can do, I will run the same command Pulumi up, and here you can see it is creating. I will do yes here. So it has created my new bucket here, and now let's create a EC2 instance also using Python now. So I will say create an EC2 instance. So now for creating EC2 instance, what I can do here is I will say instance is equal to aws.ec2 okay, so they are importing only S3. I will import from Pulumi AWS import EC2 also. So now here I will say instance is equal to EC2 dot instance here I will assign a name to it. Let's say my instance, my instance, and here we will assign some other things. Let's say instance type. So instance type will be T2 micro. Now assign the AMI also here. So AMI will be the same Ubuntu AMI that we used. Now after AMI I will say tags, and tags will be name, right? So name will be as, let's say, web server, we can say my new or something. So okay, now let's run again the Pulumi up command. Let's do yes here. In AWS console you can see there is no instance now. It has been terminated, my EC2 instance. Now it is creating my instance here. So now it has created my new instance. So if I do refresh here, we can see web server new instance is created and it's running now, right? So now we can destroy this whole infrastructure using Pulumi destroy. So here this was the basic tutorial how you can use Pulumi by using your familiar languages like Python and JavaScript to manage your AWS infrastructure. So we have seen how you can use Python and how you can use JavaScript. So same as these, you can use other languages as well. Like you can use Golang also. You can use TypeScript also for creating or managing your AWS infrastructure. So now you can see my bucket and resources are deleted. So it is saying also, if you want to remove the stack completely, you can run this pulumi stack remove ls remove dev command, pulumi stack remove dev. So my dev stack will be removed. So now dev stack is removed. If I do pulumi stack ls, so it will say there is no stack. So how you can create a new stack? You can run pulumi stack init dev, and your new dev stack is created here, right? So this was the tutorial how you can use Pulumi to manage your AWS infrastructure. So before moving forward with this video, I want you to go through this playlist on our KubeCode channel. This playlist is DevOps Complete Hands-on Project series. So this series is a comprehensive playlist on YouTube designed to provide you with practical experience in implementing DevOps practices and principles and tools in real world scenarios. So this series is aimed at both for beginners and experienced developers who want to gain practical experience in DevOps workflows and learn how to use popular DevOps tools and technologies effectively. So now let's see how you can provision or manage your Google Cloud infrastructure using Pulumi. So first of all, here we will use two languages. First, we will use JavaScript to see how you can provision your GCP infrastructure using Pulumi. Then we will use Python as well for creating GCP infrastructure, right? So first of all, let me create a directory here for GCP Python. Let's say GCP Python Pulumi, and the another directory for JavaScript, GCP JavaScript Pulumi. And I will go to, first I will use JavaScript, right? So now here I will start a new Pulumi project for my GCP infrastructure using JavaScript and Pulumi, right? So here what I will do, I will just run Pulumi new, and template I will use GCP JavaScript. I will hit enter here. You will see here we have some options like GCP JavaScript Pulumi, project name, enter, and stack name will be dev as default, and passphrase I will keep it empty. Now what is our GCP project? Just copy the project ID here and paste it here, right? Now it is installing the dependencies that are required to provision GCP infrastructure using JavaScript, right? So now you can see all the dependencies are installed and our project is ready to go. Now if I do ls here, so you can see we have some files here. One is pulumi dev.yaml, pulumi.yaml, index.js, package log, and these are some files related to JavaScript. Now just open it in VS Code. So now I am here. You can see in index.js I have this file here, index.js, and in this index.js file we can basically configure or define all the configurations in a declarative form that we want to configure in GCP, right? Any infrastructure, any GCP resource we want to create, we can define here. Just like here as example, you can see we are creating a bucket, right? And the bucket is like we can create in this form. Bucket is equal to new GCP, and this GCP we are requiring from Pulumi GCP. So this is a dependency which Pulumi automatically installed, and it also installed Pulumi dependency as well in Node.js. So here we can use this GCP dependency and we can work with GCP. Same like here, you can work with different providers as well, like different cloud. Like let's say you want to work with Kubernetes here, so you can also install Kubernetes provider using Pulumi. That package you need to install using npm, and then you can start working with Kubernetes provider within this Pulumi project, right? So now here we have this bucket, and let's say if we want to create this bucket, so what we need to do, we need to just run the pulumi up command. So first of all, let's say if I add some name to the bucket, so I will say my first bucket 123 using pulumi, right? Add a comma here because it is a JavaScript object, right? Now here what I need to do, I need to run pulumi up command. And here I will do yes, and you can see it is creating a stack and then it is creating the bucket. So if we go to my GCP console, here you can see in cloud storage buckets, you can see two resources are created, this bucket is created and this is the bucket name, right? If you go to here, you can see my first bucket is created here. So now if I like to want to destroy it, so what I can do, I will just run pulumi destroy command and it will destroy this all the resources which we have defined in the pulumi configuration file, right? Not only a file, a pulumi configuration file, instead this complete directory, this complete pulumi project. So it will provision every resource which is defined in this complete pulumi project, right? So now our resources are deleted. So now we saw like how you can work with JavaScript in Pulumi for generating your GCP resources. Now let's see how you can work with Python as well. So just go back into the main directory. Now let's go to GCP Python Pulumi, and here I will initialize a new project, new Pulumi project using Pulumi new. Here I will add Python, or sorry, GCP Python, right? Now it is asking me some options, and GCP project, this is the GCP project ID. Now it is installing the dependencies, and you will see it will automatically create a virtual environment in Python for running your Pulumi project. So now you can see your project is ready to go. I will open it in VS Code. Now you can see if I go to terminal, you can see it has run a command source, this activate. You can see this is the path of my directory, and it has activated this virtual environment here automatically, right? So now here in this main.py file, you can see we are creating a bucket here. Bucket is equal to storage.bucket, location is equal to US, right? So this is the same way, all things are same, but we are we changed the language, the programming language we are using here to generate our GCP resources. So here we can use Python as well, and same as Python or JavaScript, you can also use you can also use Golang, or you can use any other language which Pulumi provides. So it is the reason for using Pulumi for you, because let's say if you are proficient with Python or you are proficient with JavaScript, so in whether language, in every language you are proficient, no matter what it is, so you can use that language and you can generate your infrastructure, you can use your code as for generating your infrastructure, right? So here also you can run pulumi up command and pulumi destroy command, it will generate this bucket. So this was just a demo. In this video, in the next chapter, we will see how you can use Kubernetes provider with GCP cluster, right? So we will use two providers, one is for GCP and one is for Kubernetes, right? So now let's go through our steps how we can deploy this React application to GKE. So here you can see this is our directory structure. In our directory we have two directories, one is for to-do list application and one is for Pulumi code. So in this you can see we have already a directory for React to-do list application. Here if you want to know about how to build this kind of a to-do list application, so you can check out our video. We already have how to build a to-do list application with React. So I already have a Docker file here inside this for this React application, you can see. So now just go through this React application. Let's see how it looks like. So I will go inside this and I will start my React application in a development environment using npm start. So here you can see this is a to-do list app. I can remove tasks, I can add tasks, let's say task or something here, add task, I can remove task. So here it is running on my development server. Let me close it. Now what we need to do is we will build this application using Docker and we will publish it as a Docker image on GCR. Then we will use that Docker image to deploy this application on GKE. So here we have the Docker file. Now what we need to build this image and then we need to push it to GCR, right? So here you can see the step is build Docker image for our React to-do list application. So we can use this command build docker build and we will use this host name, and this is a specific path we need to assign to every image if we are deploying any image to GCR, right? So here we will have the project ID or GCP project ID and this will be our image name, right? We can also add tag here, so it will keep the latest if we are not passing any tag here. Then we will push this image to GCR. Then we will start writing our Pulumi script. So first of all, let's build our Docker image. So I am inside my directory for my React application. In my React application directory, now I have the Docker file here, right? Now I will run docker build tag us.gcr.io and now I will add the project ID, right? So my project ID is this. Now after the project ID, I will add the React to-do list app. So this will be the image name. So let me change a little bit here, to-do list app, right? So, and from where I want to build this image, from the current directory, right? So now it is building the image for my React application, right? So if you want to go through this Docker file, you can also see here we have two base images here. First we are taking Node.js as a base image and we will build this application using npm run build, right? Then we will take this build folder from the builder, this builder step, and we will take this build folder and we will copy this build folder from builder to our nginx folder here. So we are taking nginx here as a base image. So now it is building, it is running all the steps that are defined inside the Docker file. So now it is running npm run build. So now if you want to go to the GCR console, so you just need to search GCR for the container registry, and inside the container registry you can see your images. So this is a image already, React to-do list app that I have already, but I will delete it. I will push my new image here. Now you will see there is no image. This is my service image, and now my image is built here. Now I will check the images using Docker images. So you can see here I have this image us.gcr.io, this complete. I will copy this name of my Docker image and I will push it, right? So it will be pushed to my GCR, Google Container Registry, right? So I am already authenticated with my Google Cloud. If you want to authenticate with your Google Cloud, you can authenticate using gcloud. So you just need to install the gcloud SDK in your local machine, and then you can just gcloud init or gcloud login. So you will be logged into your gcloud account, right? So now my image is pushed here. Now if I refresh it, you can see my image is here and it is pushed inside the GCR, right? So now let's see the next steps. So our next step is we need to start writing our Pulumi scripts. So first of all, we need to create a directory for our Pulumi code. So I'm creating mkdir Pulumi. So I have created a Pulumi directory. Okay, sorry, I have created this directory inside the React application. Let me go outside of it, and now I will create the Pulumi directory here. So my Pulumi directory is created. Now I will go inside the Pulumi directory. Now I need to initialize a new Pulumi project. So I will use GCP JavaScript template for it. So project name I will keep as React GKE. Description I will not add anything. Stack name I will keep it default dev. For passphrase I'm keeping it empty. So for the GCP project I will provide it the GCP project ID. So now it is installing all the required dependencies that need to build the infrastructure for our Google Cloud, right? Okay, so now it's saying your project is ready to go. Just ignore these warnings for Pulumi new version. Now let's go inside, go through our Pulumi project. Here you can see it has installed node modules, and there is a index.js file, right? So inside the index.js file you can see the code is there for creating a GCP storage bucket, but we do not need to create any storage bucket here. So I will remove this code, and I will remove this export variable also. Now what we need, if you go to the steps here, so you need to install another package for Kubernetes. So here you can see we only have packages for like the Pulumi and GCP. I have package only for GCP, but I need to configure Kubernetes provider also, because I need to deploy some Kubernetes objects, right? So deployment object and load balancer service. So I will install another dependency. So you can see the dependency is npm install Pulumi Kubernetes. So I need to install it, right? So just run this command here, it will be installed. So now we need to set the GCP project. So GCP project is already set. If you go to pulumi.dev.yaml, you can see GCP project is set here. Now what we need to specify the location. So I will add this configuration also. So I will say Pulumi config set GCP location US Central 1C, right? So here you can see my location is added inside this GCP. So what is config here in Pulumi dev.yaml? So what is Pulumi dev.yaml? It is basically a file, a setting file for my dev stack. So Pulumi works based on stack. So I have created the dev stack as default. So inside the dev stack we have this settings file for the dev stack, and here I have configs. So configs just like variables you can use inside your code, right? So these are some, you can also have secrets inside this, but you can also have directly the config variables like this. So what is GCP? So it's just like a prefix, like let's say if you want to have some variables or configs related to GCP, so you can have GCP as prefix here. If you want some Kubernetes config, so you can add Kubernetes here. Also you can create some direct some variables kind of in configs, right? So now let's go to our index.js. Now we have installed a new library, you will see here, that is Pulumi Kubernetes, right? So now we need to require it. So I will say const Kubernetes is equal to require Pulumi Kubernetes, right? Now what we need to do, we need to write the code for creating our cluster, right? So here also you can see we need to require this location, right? So GCP configuration, right? So as you know, like we have these config variables here, so you can require these config variables inside your code and you can use it, right? So how you can require them? You just need to run like GCP config. So I can require every configurations, like for GCP, if I have some AWS, so I can require some for AWS config. So I will add here new Pulumi config dot config and the GCP. So I need config variables for the GCP only. So this will require only GCP variables like location and project, right? So now just set here region is or zone, sorry, yeah, right, zone is equal to GCP config dot require location, right? So why I'm adding location here, you can see in pulumi.tab.yaml it is GCP location, right? So I'm requiring this location, so this variable will be fetched here inside my code, right? Now what we need to do is we need to create a GKE cluster, right? So if you are using a free trial account in GCP, so just follow my rules, what I am setting here, just follow my same configurations here for the cluster. So here what you need to write for creating a GKE cluster. So we will write code, let's say const cluster is equal to GCP dot container dot cluster, right? And inside the cluster just specify the name, let's say my cluster here. Now you will specify your main arguments, your metadata for your cluster, right? So first of all, the name. So name will be my first cluster, and location we already have zone here, so we will provide this variable here, zone. Now initial node count, how many nodes we need, let's say 3, right? Now minimum master version, we will say latest, right? Now add the node configurations, machine type, so just follow the same for this node configuration, because if you are using gcloud free trial account, right? So machine type we will keep G1 small and disk size will be only 32, right? So just keep the same configuration as I did here for the cluster. And now when we create the cluster, so it will give us an endpoint for the cluster, right? So that we can connect with it. So for the endpoint, let's export the variable for the endpoint, right? So exports dot cluster IP is equal to cluster dot endpoint, right? Now it is set as output, so it will give us the output. So can we start running our Pulumi scripts? So it will create the GKE cluster. Yeah, we can run our Pulumi scripts. So but we need to write the deployment and load balancer service also, but we will keep that later, we will do that later. But now let's create our GKE cluster first, right? So what we need to run, we need to just run Pulumi up command. So Pulumi up will run this code and it will create all the resources that we define inside the JS script or any script you are using for Pulumi. So I will say Pulumi up, I will keep it blank. So we are getting an error here like invalid or unknown key. So we are getting this because of this location. So in GCP there is no config like location. So let's add zone here, and here also we will define zone, right? Now just run the command Pulumi up and let's see. Okay, so do yes. So now it is saying it is creating the cluster, right? So now in the console, let's go to Kubernetes engine and let's see our clusters here. So you see it is being created, my first cluster here. So let's wait for it, let it be created. So after the creation of this cluster, what we will do, we will write the configurations in Pulumi for creating a load balancer service and a deployment object. Then let's go to a new tab and let's see our image, right? Our Docker image we have published to GCR, right? So just search here container registry. You can see our application image is here, React to-do list app. So it is a private image in private container registry here. So let's see, our container cluster is being created. It takes some time to be in the running state, so let's wait for it. Yes, so now our cluster is created and it's saying here it is in the running state, right? So now what we need to do is, first of all, we need to configure a Kubernetes provider here, right? So we have already installed Kubernetes package for our Pulumi here. You can see Pulumi/Kubernetes. And now what we need to configure the Kubernetes provider, because we need to connect our this cluster to our Kubernetes provider, right? So that our deployments and our all the Kubernetes objects can be created inside of this cluster, right? So let's say you want to connect this cluster to your machine, to your local machine, so you can use this command, right? But we have created our cluster using Pulumi infrastructure as code, and now we need to add some configurations here so that it will be connected, right? So if we go to the Pulumi documentation here, they have this tutorial how you can configure the Kubernetes provider for GKE, right? So there you can find this kubeconfig file that we need to create. So you just need to copy it, right? So this is export const kubeconfig, and so this is a basic kubeconfig file. And in this, basically you need a GKE gcloud auth plugin also installed in your local machine if you are running, so you can install using gcloud components. So just copy it and paste it here. You can say define or kubeconfig. So this is the kubeconfig file I have added here. Let's see first all the variables are correct or not. So gcp.config.project we have .zone. What is name here? Name is coming from this parameter here, right? Now cluster.endpoint, cluster is okay, all things are okay. Now context we are creating here. Okay, now everything is okay here, right? So now we have our kubeconfig here. This is basically a variable. Now we need to use this kubeconfig to add the configurations for Kubernetes provider here. So you can see we need to create a Kubernetes provider that use our cluster, right? So we can use this code. We can just copy it and paste it here. So you can see kubeconfig, we are taking kubeconfig from this variable that we have specified or declared before, right? And name, in this name you can specify, let's say Kubernetes provider here. Okay, so now we have created a cluster provider. So now we need to use this cluster provider every time when we need to create or deploy any Kubernetes object here, right? So first of all, what we need to deploy here, first we need to deploy a deployment, right? Kubernetes, create a deployment for the application, right? So now if you go to here this repository, so sometime before we did a project where we deployed this there was a Node.js application. We deployed a Node.js application to GKE, and there we used this deployment YAML file. So here we are not using YAML file, we are only using Pulumi, right? So using Pulumi, how we can do that? So you can see this is the configuration. We need to apply the same kind of configuration for the deployment, but we will use Pulumi here. So first of all, what we need, their API version v1 and kind deployment. So first of all, just create a variable deployment is equal to new, and here use Kubernetes apps.v1. You can see here we were using apps v1/v1 version here, right? From v1 what we need to create, we need to create the deployment, right? So what will be the name of the deployment? First specify, let's say my deployment or something, right? Or let's say app deployment. Now here the second file, this object, sorry, we need to add comma here. Here in this object we need to specify our main configuration for our deployment. So you can see what is the main configuration here, metadata. So add the metadata here, right? So in metadata let's add the name. So name, let's say app deployment. Okay, and then what we need to add here, you can see in the YAML file as the same. You need to add spec, open a object here for specs. Now inside what we need to specify, replicas, how many replicas we need. So we will add the one replica here. Okay, now what we need to add, we need to add the selector here. So you can see selector, we need to match labels. So labels, like we need to add some labels on some pods, so on some containers also, right? So you can see this is the template for the container, for the pod. So in the pod we are also adding the labels. So these two labels, like type backend and app node app, these two labels we need to match here for every replica for the selector. Okay, so now for labels we are not adding every time here the same labels. Let's create labels before. So I'm saying const react app labels, and I'm creating an object here for the label, and the label I'm adding app react to do app. Okay, and here match, here I need to add selector, right? Or in selector I need to add match labels. So for matching labels I will add this variable here only, react app labels. That's it, right? So now in the spec we need to open template. So here we will define the template for our pod. So here add the metadata. On metadata we add the labels. So labels we will add the same react app labels, right? So in the template also for the pod we will specify the specs. So let's go here. You can see in the template also first object was metadata. So this also had some name, and another one was object was specs, right? So here we will specify the containers, or containers will be inside the pod, right? So here add spec, right? Now in specs add containers name. So for containers you focus here, if you notice this container is not an object, so this will be a list, right? So just open here a list, not an object, JavaScript, and here first object will go for first container. So we will have only one container in one pod here. So we will create it, and let's specify the name. So name will be, let's say app container or react app container, right? Now the image, so this is the main variable here for the image. So image, let's see what was the image URL of our application. So if you can copy, you can copy here, copy full image name, and you can just paste it here. So you can see us.gcr.io/our project name and the image name, right? So I'm just removing this SHA here, we don't need, because it will select from the latest tag by default, right? Now specify the ports, we need to open some ports here. Okay, let me add the comma, ports. So ports will also be a list. So first port will go container port, that will be 80, right? Okay, so this is our configuration for our deployment here, metadata, specs, and now what we need to configure the provider here. So what was the provider we created? This cluster provider. So use that here. Open a new object here, add the provider. Provider will be cluster provider, right? So now our deployment configuration is ready here. So now what we need to do, just run Pulumi up and let's create our deployment, right? Okay, so what's it saying? Export const. Okay, okay, so that was, so this variable was for TypeScript here, so we cannot use like this. I will not export it. I will just use like const cube config is equal to. Okay, now just hit Pulumi up. Do yes. Okay, so it has created the provider, then it is creating the deployment. So it has created the deployment, right? And you can also check inside your cluster, go to workloads. You can see in your workload the deployment is ready. So you can see app deployment is okay and its status is completely okay. Now what we need to create a load balancer service for accessing this application, right? So how we can do that? Here you can see this is a YAML for creating a load balancer service. So kind service version v1. So just let's create a service here. Just create a new variable. Service is equal to new Kubernetes dot core dot v1 dot service, and here let's name it like app service, and here also specify provider. Already I'm specifying the provider, cluster provider. Now here I will add the configurations for my service, right? So in the YAML also you can see, first of all we need to add the metadata, and we need to, in this spec we need to add the type of the service, that will be load balancer, and then we need to add the selector that will select a specific labels, right? So here let's add metadata. So in metadata add a name. So name, let's say React app load, or let's say LB service. Okay, now after metadata what we need to add, we need to add specs. So in the specs first we add the type of your service, that will be load balancer, right? Now we need to specify the ports here, right? So ports will be a list. You can see here ports is a list, and here in the list add first port, that will be port will be 80. So our, this is our service port, so our service port will be 80, and the target port will also be 80 from our container, right? Now add the selectors here. So selectors, how you can add, you just add React app labels. So now it is okay, completely configuration is okay for creating our load balancer service. You can see now what we need, let's export the public IP from this service, right? So that we can access the our application using that IP address, right? So it will give us an external IP from which we can access our application. So just exports dot service public IP, let's say, and service dot status dot apply. So this is apply is basically a Pulumi kind of functionality that it provides. So it's kind of a callback function here, and I will use s as a parameter, s dot load balancer dot ingress, and so this ingress will be an array, and I will take the 0 position of the array, and here I will fetch get the IP here, sorry, IP. So this IP we will get as export variable. So now what we need to just run the Pulumi up command. Let's do yes. Okay, so now you can see it is creating the service also. So after creating the service, it will give us the output variables. So in the output, it will give us the service IP also. So using that service IP, we can access our application. So it is saying it is created, service is created, and just copy this service IP address and paste in your browser, right? So you can see our to-do list application is working here. So it is completely deployed on our Kubernetes cluster, and we did not use any manual commands. We just used this Pulumi script. So now whenever you need to deploy, you just need to run this Pulumi script, and also you can change your image if you want to deploy some different kind of app. So you can change your image URL, right? And just you need to hit the Pulumi up command and your application will be deployed. And now let's clean up our all the environments. So we just need to run Pulumi destroy, so our every resource will be destroyed, right? So it's saying deployment is deleted, service is deleting. So let it delete everything, so it will take some time. So now everything is deleted here using Pulumi. So now if you just hit the Pulumi up, so you can, your application will be deployed directly on the Kubernetes cluster. So it will create the cluster, then it will create the deployment and the service, and it will give you the public service IP, right? So using this, you can write your own, you can deploy your own application if you want. So you just need a Docker image for that. You can directly push your Docker image to GCR, and if you have any open image on Docker Hub, so you can use that also. So thanks for tuning into my channel. I hope you found the content valuable. Don't forget to hit the subscribe button to stay up to date with our latest videos. Thanks again, and I will see you in the next video.